Good evening, sir. Shall we start now, sir?
Okay.
Vijay Kumari, please start, ma.
Ladies
Please
and
start.
gentlemen, a pleasant good evening and welcome to our Industry Expert webinar. It is my great pleasure to have you with us this evening, and I sincerely appreciate you taking the time to join us. We have an exciting session planned filled with insightful discussions and valuable knowledge sharing. As we gather virtually from various locations, I am reminded of the power of technology in bringing us together. Our theme for tonight resonates with the ever-evolving digital landscape, and the insights shared today will undoubtedly be both timely and impactful. Our esteemed speaker prepared to share their expertise on fun with algorithms, a subject that is increasingly relevant in today's world. We hope this session will inspire new ideas, broaden your understanding, and encourage meaningful dialogue.
Before starting our session, I would like to request Ms. Amta ma'am to give a brief introduction about our esteemed industry expert, Mr. Sachin Lodha Sir, Chief Scientist at the TCH Research and ACM Eminent Speaker, Secretary, ACM Indian Council. Ma'am, can you please proceed?
Yes, ma. Thank you. Good evening to everyone. It's my pleasure to introduce our industry expert for today's webinar, Mr. Sachin Lodha Sir, a research leader with over 22 years experience of at TCS. Throughout his remarkable career, Mr. Lodha Sir has demonstrated exceptional leadership and expertise holding various key positions at TCS. Currently, he is working as a head of research at TCS. Previously, Sir led the cybersecurity and privacy research team for 6 years, driving innovation and excellence in cybersecurity solutions. He also founded and led the Applied Algorithms and Optimization Research Group of 16 years and groundbreaking approaches to algorithmic research. In addition to his impressive industry experience, he is an ACM eminent speaker recognized for his expertise and contributions to the field of computer science. Furthermore, he serves as the secretary of the ACM India Council, playing a key role in promoting and advancing computer science research and education in India. Today, he will share his invaluable insights and expertise with us, offering practical advice and perspectives on algorithms. We are fortunate to have him with us, and I'm sure we will all benefit from his knowledge and experience. Thank you.
Thank you, ma'am. So Sachin here. Is it okay? I can share my screen and we can start the session.
Few minutes, sir. I would like to welcome our Department Dean ma'am to give a presidential address, sir.
Okay, please go ahead.
Good evening to all. Am I audible?
Yes, ma'am.
Yeah. Good evening to all the members who have gathered in this online meeting on behalf of Kalasilingam Academy of Research and Education, School of Computing, and the ACM chapters functioning at Kare, as well as Madurai ACM Professional Chapter. I'm welcoming you all for this session. The session is going to be handled by Mr. Sachin Lodha, Chief Scientist at TCS Research. He is also serving as the ACM Eminent Speaker, and currently he is the Secretary and the Treasurer of ACM India Council. I could see that he is in such a very, very great position and very busy person. In spite of all his busy schedule, he has agreed to meet our students and address our students, especially on the title Fun with Algorithms, which is in fact my favorite subject. So all the students and almost faculty members of CAC knows that I have handled this data structure and design and analysis of algorithm subject more than 10 times. It is because of the passion I have towards the subject, and the one who is very strong in algorithms, definitely they can excel in the field of computer science. So keeping that in mind, the chapter has organized this eminent speaker session, Fun with Algorithms. Definitely we are all going to have a very good learning as well as fun with algorithms. The session is going to be handled by the very great person, Sachin Sir. Sir, welcome you to our Kare ACM chapter and Madurai ACM professional chapter. And now the session is yours. Please engage with our students and make them to feel very fun when they are learning about the algorithms. Thank you, sir.
Thank you, ma'am. I think you made several very interesting points. Indeed, I think algorithms is at the heart of computing and computer science. And I think familiarity and sort of, expertise in algorithms can help our students long way. But what I have seen time and again is that students find it very theoretical subject. Many a times they find it, little scary subject or a dry subject, and they don't take to it, and that kind of, becomes a handicap later. So, goal of my session today is, students, I'm trying to show you fun part of algorithm. In fact, what I'm going to show you is how algorithms are everywhere around us. I'm going to convince you that how you already are a great algorithmist, and not just you, someone very close to you, in your family is also a great algorithmist. And hopefully that will break ice between you and algorithms if there is any. And as ma'am rightly said, it will really help you in your career later, to have good understanding, of algorithms. I must thank organizing team for giving me this opportunity. I'm actually, my apologies, I can't be there in person. Indeed, I have very busy schedule, but I'm happy that we can meet today, right? And my sessions are always very interactive. That's why I wanted it to be this way, so that students, you can unmute and respond to, my silly questions. Okay. With that, let me just try share my screen, and you please confirm if you can see it. Just one sec. Okay. Uh, are you able to see my screen? Okay. Yeah. Any problem, just unmute and tell me, okay? But let's go ahead. So, let me just start. See, I will do it through many puzzles. Okay. Maybe we may not have time to cover all of them, but let me see if I can cover 3 or 4 of them. So we'll start with, my version of Kaun Banega Crorepati. Okay. Um, Long back, maybe many of you students, you may not be born then. There was this show by Madhuri Dixit on Kahin Na Kahin Koi Hai, right? It was about matchmaking. We'll also do a bit interesting treasure hunt. I have a nice problem for you. I have given it a tagline of the surf ad, Dhoonte Reh Jaoge. Then we'll come to a very interesting question that I'm sure girls, especially ladies, always have, to buy or not to buy. And hopefully, this discussion will give them some trick, on this decision making. Of course, so far you will see that we are just doing puzzles, we haven't discussed anything about algorithms. So to get that started, I'll take you to kitchen. This is a very important question, in life. Are you a good cook? And then we'll discuss about algorithms. I'll also tell you a bit about what we do in our labs, on algorithms. Okay. I hope this is okay. You can still see my screen. So let's go to the first game. Okay. the Kaun Banega Crorepati. So my version is little different. Imagine that after all those, telephone calls, finally you have managed to get a hot seat in front of Amitabh Bachchan, and this is what he's going to propose to you, right? So this is a problem, that there are 100 cards that kept face down on a table. They are in a row, right? And each card has some number written on it, say a positive number. You can't see that number because cards are kept face down, okay? 100 of them in a row. Now, what you are asked to do is, you are a player, so you can pick cards one by one, whichever order you want, okay? So if cards are left to right, not necessary that you have to pick in that order. You can pick some middle card, maybe some end card, whichever way you want, okay? Now, after you pick a card, you can turn it around. You can read the number, okay? And then you have to make a decision, stop or continue, okay? So I'm going to pause here. I hope you all are listening. You are seeing my slide. Is the game clear to you? Can I hear some yes? If there is any no, please tell me.
Yes, sir, we can visit.
It's clear.
Clear, sir.
It's a very simple game. Visualize this: a table, 100 cards face down in a row. You are picking them in any order. You read the number. You have to decide whether stop or continue. Okay. Now let's move on to the next slide. Now remember, so I said it's my Crorepati game, right? Kaun Banega Crorepati. So I'm going to gift you 1 crore Bolivar. Okay, you can just Google and see which country's currency this is. It's not very highly valued currency, so this is not a lot of money. Okay, but anyway, that joke apart, see, the game is this: if you decide to stop, okay, and the number at which you stop, that card has that number, right? If it happens to be the maximum number among all 100 numbers, right, then you win. Otherwise, you have to, you lose, you go home empty-handed, right? So how will you play this game? Okay, again, remember, 100 cards face down, any order you can pick. You turn around, you see the number, you can decide stop or continue. If you continue, pick another card. If you decide to stop, the number at which you stop happens to be the maximum among 100 numbers, those 100 cards. Look, you have probably decided to stop after, let's say, 20th card. You haven't yet seen 80 cards, okay? So you not have seen all numbers, yet you decided to stop. If it happens to be the maximum number, you win. Okay. So my question to you, I hope you all understand this game now. Okay. Is it clear? Any questions? Hello. Is it clear?
Yes, sir, it's clear, sir.
It's clear, right?
Yes, sir.
Okay. So my question is now, how will you play this game? So to make you think, let me ask you one very simple question. Will you stop at the very first card? Anyone? Yes, no? What is the probability of winning if you stop at the first card? Let's say your strategy is that I'll pick some card, I will read that number and I'll say stop. What is the probability you will win? Anyone? Look, you don't have to be right. You can be wrong, but discuss with me. Through discussion only you will learn. What will happen if you decide to stop at the very first card? What is the likelihood that it will be a maximum value card? Remember, there are 100 cards. Anyone?
1 by 100, sir.
1 by 100, right? Is everyone with me? Is 1 by 100 correct? Do you agree?
Yes, sir. Most of them are sending the messages.
I couldn't hear you, but good you spoke. Anyone else? Students, speak up. If you don't speak, you will not go anywhere in this world. I hope you know this,
The
right?
probability will be 1 by 100.
1 by 100, right? Everyone agrees? Some more voices?
Yes, sir. We agree to that.
Okay.
Yes, sir.
So now let me tell you another strategy, okay? My other strategy is that I will look at all the cards and finally stop at the 100th card, okay? You see my, so first strategy was I'll pick first card, just stop there, say that, okay, this is it. The probability of winning is 1 by 100 because the card I pick should have maximum value and that probability is 1 in 100, right? Because there are 100 cards. Now my other strategy is that I will wait till the 100th card, and then automatically I will have to stop because no cards are left. What is the probability of this strategy winning? Remember, I'm stopping at the 100th card, and by luck, I need to have it as a maximum valued card, right? So, what do you think will be probability that 100th card will have the maximum value? Will it again be 1 by 100? Because any card could be last card, right? What do you think?
Sir, do you mean that you are going to take all the cards or only the 100th card?
No, no, all cards. No, see, I will look at all cards. I'm not going to
Then
stop.
the definitely probability will should have
1 by 100, right?
Yeah.
Because, see, remember, the card on which I stop should have the maximum number. It is not that I should have seen the maximum number of cards in the earlier cards. Wherever I stop, that card should have the maximum value, right? So if I wait till the 100th card, probability that 100th card will be the maximum value card is again 1 by 100, right? Because any card could be maximum, any card could be the last card, right? Depends on which order I pick. So is this clear? I mean, do you understand the game? Do you see that there are these two strategies? One is a very aggressive one, stop at the very first card. One is very lazy one, which says wait till the last card and then stop. And both have probability of winning 1 by 100. Are you with me so far?
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So now let me start teaching you how to solve algorithmic problems. Okay. See, a typical trick in mathematics and algorithms is to link it to a problem you already know how to solve. Okay. And if you can do that, then the strategy just comes out like easily, there is nothing to be done. And I want to give you now this illustration here. Okay. So let's step back. I want you all to think and tell me what real life situation this game is modeling. Where do you face this kind of situation that there is a series of numbers coming, and you have to stop or pick the maximum number? Can you see any real life situation where this happens? I'm telling you, it's so common. When I tell you, you will kind of, scratch your head. But anyone, what real life situation this is modeling? So let me give you a hint. Share market.
Yes, sir. Share market like that.
right?
trading extra that, yeah, definitely.
See, imagine that you are holding a TCS share. Every day morning, you check what is the price of the share, you know, and you actually want to sell it at a maximum price so that you can make maximum money. Is this okay? Do you think this models that, right?
Yes,
So,
sir.
so if you agree that this is modeling something so common nowadays in India, right? Everybody is in share market. How do you do this? Do you will you sell the TCS share on the very first day? Does that make sense?
No, sir. No, sir.
No.
No, sir.
Will you wait all the way? Let's say you have decided that I want to sell this share in this, next 4 months. Will you wait till the very last day and sell it?
No, sir.
No, sir.
We will wait for our target.
Yes, but how do you do this? How do you know your target?
At least we will wait 1 or 2 quarters.
Okay, to decide the target.
Yes,
Yes,
sir.
sir.
Okay, so let me rephrase what you are saying. You basically are saying that we will watch how share price is behaving for first few days, and post that we will know, right, that what is our target, and in the remaining period, first time share crosses that target value, we will sell it. Is this is this how you will do it?
Yes, sir. Similar to.
All right, and that's what you will do in this game also. Okay, so I hope now you see the point I'm making. You all have a strategy for a share market, but I'm telling you, you did not think of it. When I told you this problem, you were all puzzled. You were thinking that this is some very difficult problem to solve. But I hope now you realize that it is something that is inspired from real life. And in real life, you are all solving this problem. Okay. So let's put it little mathematically. Okay. So here is a strategy. Can everyone go on mute, please? See, here is a strategy. So I said that we will watch for the first few days the share price. Likewise, I'll tell you what is the value of this variable x. Okay. What we'll do is we'll pick some cards randomly first. If it makes you easy to understand, imagine x to be 10. Okay. So let's pick some 10 cards randomly from this pack of 100. Find out what is the maximum value among those 10 cards. Okay, fine. And you call it some, we all are computer people, we know, we write some variable, right? We'll say it's a x max. Now you start picking from the remaining cards, and the first time you find a card that has a value greater than that target or baseline value you had, yeah, x max, you stop. This is our strategy. So I have now questions back to all of you. This is this okay? Do you understand? My first question. Second, do you see this is closely mimicking what we discussed for the share market?
Yes, sir. Yes, sir.
Oh, yes, sir.
Right? As students, I am not able to see who is speaking, but I'll really urge all of you to participate. See, if you remain shy or you remain sort of thinking, I will look silly if I answer wrong, then trust me, you will remain silly all the life, right? You should be bold, you should think, you could be wrong few times, but eventually you'll be right. Okay. So don't fear, just speak. Okay. Now, if this strategy is clear to all of you, okay, now we have to find what is the probability of winning. Okay. Now I want you to, I'm not doing that math here, but I'll give you a hint. You all should look for, so this is also known as a secretary problem in the literature. And why is it a secretary problem? Because it's a very similar situation. I announced a position for secretary in my office. I get number of applications. I interview them one by one, and I'm giving decision then and there. But I want to finally, I mean, whenever I stop, that is, whenever I say yes, I pick a person as a secretary. I want the best person. Okay. So in some sense, so this is how this problem is known in the literature, secretary problem. You look up for that. It is very widely studied, okay, and it has a lot of implications for economics. In fact, for even your real life scenarios, like I said, share market. Okay? So what this says is, this formula says, so n here is the total number. In our case, n was 100, right? We had 100 cards. X is the, we said, our observation window, right? We said we'll pick some X card randomly and we'll observe, the target value from that. And then we will, start picking from the remaining cards. So this says for a given X and N, the probability of winning is this particular formula, okay? Now, I want to maximize this, right? I want to find such X so that this probability is maximum. Can you quickly tell me, given a function, how do you find its maximum value? You all have done this in your 11th and 12th. How do we find maximum of a function?
It is greater than another and another.
Yeah, but how do you find it? You remember we take derivative. First derivative has to be 0, right? So what we do is we take derivative of this and equate it to 0. If you do that, you will find that X actually turns out to be n upon E, okay? And if you put this back in this formula, then you will find that maximum value of probability P is 1 by E. So in literature, this is also known as 1 by E stopping criteria. Okay. Let me show you a graph and it will become clearer. If you see this observation window X, if we vary it, so let's say that we look at only one card versus we look at all cards. This is how the probability Px will be plotted, okay? And you will see that the maximum value is about 0.37, and that is achieved for actually 37% itself, okay? This is very interesting math, but I don't want to sort of confuse you with that. I just want some very simple, easy answers from you. One, do you understand the game? Did you understand the game?
Yes, sir.
Yes,
We
sir.
understand.
Right? Secondly, do you remember that we said probability of winning is just 1 by 100, right? For some very simple strategy, like stopping at the first card or stopping at the 100th card. Do you remember that?
Yes, sir.
Yes.
Are you now impressed that we have actually achieved 37% winning probability? Do you find that very impressive? We were thinking of 1%. Now, with this particular strategy and picking right X, you can actually win with probability of 37%. Do you find that impressive?
Yes, sir.
Yes, sir.
7% is so much last time.
Yeah, it's, oh, you see, first time when I read this result, I was totally, very impressed. I was just, wondering. I mean, this looked like a magic to me. But you can see that the strategy is not a rocket science. This is a strategy we apply in everything we do in life. Okay. So just to sort of spur some more thoughts. For example, let's say that you are going for a property hunting. Do you buy very first property you see?
No, sir.
No, 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 sir.
See, anything and everything we do in life, we typically observe for some time. We look at some samples. We create this target, as you someone called it, or a baseline, and then we again look for more. And whenever our baseline or target criteria is met, then we go for it, right? So you will see that this is a pattern we use everywhere, which is what this game was all about. And if you do it smartly, with very high probability, you can actually come out successful. Okay. And this is quite popular uh, criteria, the 1 by E stopping criteria in literature, and is applied in number of fields. Okay. So I'm going to pause. This finishes our first puzzle. Did you like it?
Yes, sir.
Yeah. So I will urge all of you to look for secretary problem or 1 by stopping criteria. There are even Wikipedia pages. Read about it. Okay. And meditate. And always remember, I said the first principle for any algorithmic problem solving is to visualize and try to relate it to something you already know, right? In this case, we related it to share market. Okay. Now, let's do the second problem. Uh, so this is again a puzzle. This is how it was formulated in 1931. Okay, so I haven't cooked it up at all. Okay. Of course, here a picture of Madhuri Dixit with her husband. Okay, so you will see that this is how it was formulated, that there are n girls, n boys, and let's say that let's say there is a dancing competition and girl and boy has to be paired, or maybe even marriage. It was actually formulated as a marriage problem, but essentially some kind of matchmaking. Okay. So now girls are of course always thoughtful, and they basically sort of give, their preferences, say for the partner. Boys don't have choice. They are happy to say dance with any girl. Now the question is, we actually want to make sure that girls are happy. So we want to sort of, pair them off with a boy from their preference list. Okay. This is precisely how this problem was formulated. But let's forget that. I think you see now we are talking about matchmaking, where girls have given their preferences, and we ideally will like to make sure that girls basically find a partner from their list. That said, my question to you is, now you remember every puzzle I'm going to show you, my first question is going to be, what real life situation, forget, I mean, of course, shadi.com and all, obviously, but otherwise also tell me all other real life situation this problem is modeling. So do you think that principal in your college or dean ma'am, do you think they actually have to solve this problem in every semester? Hello. Who is solving this matchmaking problem? Do you think TCS has to solve this problem? Can someone speak? I mean, anything. I mean, you can say yes, no also.
Maybe, sir.
Do you think TCS has to solve this problem?
Yes.
Yes, sir.
No, sir. We are not.
Okay. See, I'll tell you why TCS faces this problem. You imagine that we have thousands of projects and we have lakhs of employees. Do you think we have to pair projects and employees? Right?
Yes, sir. Yes, sir.
Yes.
Now what happens is every project has a preferred skill set that they look for. Of course, every employee also has a preferred project, because of location, because of technology it uses and whatnot, right? And we have to do this matchmaking. This is a problem HR of every company is solving all the time. Okay. Then I asked you this question: do you think your principal or dean ma'am solve this problem every semester? What is your answer? Now you get the idea what I'm asking. There is always matchmaking happening. Do you see any matchmaking they do every semester?
Yes, sir.
Which one? What do they match?
Faculty selection.
Faculty and courses they teach, right? See, every faculty member has a preference for the course he or she wants to teach. And of course, all courses should find a good faculty member or a more sort of passionate faculty member to teach it, right? So your principal ma'am every semester, they have to figure out this matchmaking, right? Do you think that uh, airlines have to solve this problem?
Yes, sir.
Hmm? Right? Because they also have a staff, right? And they have airlines, and they all run on a particular schedule, and people have choices. See, this is a very, very ubiquitous problem. Don't get, I mean, shadi.com is a very obvious thing, but this matchmaking in some shape and form, all of you will do as you become senior in your organization, right? That you have resources, you have activities to be done, and you want to pair them off, right? And this is something you will do all the time. Okay. So this is just a way to motivate the problem, but funnily, this is how it was motivated by the Hungarian mathematician. Okay, I'll come to that. Now let me ask you one something called as a marriage condition. Okay. And tell me if it makes sense. So, for example, before you read that statement, let me ask you this question. Imagine that there were, say, 5 girls, but their preference list, if you look at, you combine their preference list, together there are only overall 4 boys they will like to pair with. Do you think it is possible then to do a satisfactory matchmaking if there are 5 girls, but together they have given preference of only 4 different boys? Can you do satisfactory matchmaking? Or imagine that 5 different faculty members, but they basically together say that we can only teach these 4 courses. Now, of course, each one has to teach one course. Do you think you can do proper assignment?
No, sir.
No, right? Because there are just too fewer boys in this case or too fewer courses in that case, right? And therefore, some faculty member will have to teach a course he or she doesn't like. In this case, some girl will have to be paired off with a boy she may not have liked. So this is called as a marriage condition. Instead of 5, I mean, this is more generic statement. But if you have, say, certain group of R girls who together like less than R boys, then there is no way you can do satisfactory matchmaking, right? They must like at least R boys, different boys. What was very interesting was, so there was this mathematician Hall who studied this problem, and he basically showed that while this marriage condition is sort of necessary condition to be satisfied for a perfectly good matchmaking, he also showed that it is sufficient in the sense that he said if given data satisfies this condition, you can always find a very proper matching. Okay, this is what he said. And this is very, very strong result because it basically shows that a necessary condition is also sufficient. You can do a perfectly good job. He actually gave an algorithm to do that. And you will find a lot of it in what is called as matching theory. Okay. So this kind of matching or assignment problem, again, I repeat, is very, very common. You all will at some point face this because there is always resources and activities to be accomplished, done. Matchmaking has to be done. Okay. So again, I will urge all of you to look for Hall's marriage theorem. Again, there are Wikipedia pages, read about it. But even if you don't follow math, always ask this question, what other problems I can solve if I know this algorithm? Okay. What real life situation it models? These are very important questions to ask. Of course, Google search has to be done very carefully because I have seen that when you put hall and marriage in a Google query, it will tell you marriage halls in your vicinity. Okay, so you have to be very careful. Okay, but this was a very interesting combinatorial matchmaking problem, very ubiquitous. You will again find it everywhere. Okay, so if that's understood, I mean, have you understood any yes, no, any questions on this before I move to the third one?
No question, sir.
Okay, so let's quickly move on. Now here I want your help. This is a very interesting problem, but I'm sure you all apply some thought, you will solve it. So imagine that there is a straight line. Think of it as a x-axis, in a graph we plot. And imagine that there is a blind person standing at the origin on that line, on that road, whatever. Now there is a treasure box with sort of a lot of money lying somewhere. Okay, on that straight line. This blind person has to find that box. Okay, remember, blind person cannot see. So blind person does not know which direction this box might be and how far it is. Okay. Yet you have to help the blind person sort of get there, be successful in finding it. So I want you to think for a minute or two and tell me how you will do it. Remember, my next question is going to be, where do you think this has application? What real life situation I'm talking about? So think of both this. Tell me how you will do it. Also, if you know what real life situation this might be modeling, tell me.
He just can't see, but he can hear us.
Sorry, I couldn't hear you. Can you please repeat?
As he is blind person, he just can't see, sir, but he can hear us talking.
No. See, this box basically does not send any signal. So there is no audio, anything. Box is just kept somewhere. It's static thing. And he has to sort of, walk along the line and somehow stumble upon it. He knows it is kept somewhere on this line, but he does not know which direction and how far. I hope you understand the problem, right? All of you. Any thoughts on this? How will you do it? So remember, solving a problem always start with some simple thing, right? For example, what happens if we just says that I will walk in the positive direction on the x-axis and keep walking. Do you think he will be successful? Is that a good strategy? Sorry, there was an echo. I couldn't hear you. Can you please repeat?
50% possibilities.
See, because if the box is on the negative side and our man keeps walking on the positive side, he'll never succeed, right? So he can't keep walking on one side, right? So what do you think he should do? Should he just walk in one direction, or he should look on the both the sides, little bit?
Both the sides.
See, so ideally what he should do is look a bit on one side, then come back to origin, go to the other side, look a bit, again come back, and sort of till he hits the box, keep increasing his radius of search, right? And I hope you relate to this strategy. So this is actually known as a doubling strategy. And I'll just show you a simple code. I have written it with your, C-like notation. But you tell me if you follow this or not. Just read about it, He's basically, so initially L is set to 0. So 2 raised to L will be 1. So he will travel 1 in positive direction, come back. Now that L plus plus means L is now 1. So he will now travel 2 raised to 1. That is 2 in the negative direction. If he doesn't find it, he'll come back. L has become 2. So he will travel now 2 raised to 2. That is 4 in the positive direction. Again come back. Then walk 8 in the negative direction, come back. 16 in the positive direction, come back. Do you see this sort of oscillating behavior?
Yes, sir.
Yeah. And it is called doubling strategy because every time he changes the direction, he'll walk double in that direction. Okay. That's why it's doubling. Now, my first question is, does this strategy work? Do you think this will eventually find the box? Will it find? Yes, no?
Yes, sir.
Yes, because at some point he'll hit the box because he's looking in both the direction, right? Now, you never answered this question. Where do you think this kind of algorithm, this kind of strategy will be useful? Who uses this? Where do you think we might want to use this?
Trial and error method.
I am sorry, see, some of you, when you are speaking, no, your voice is breaking. Can you please repeat?
Any problem which works with trial and error method.
Trial and error method. That's correct, actually. That's a good, smart answer. See, a specific use case is robots, basically, that cannot, that because of limited power, they cannot have vision, So, in some sense, blind robots, which have to explore a terrain, and find something. So this is kind of very basic 101 strategy they may have. Okay. Now the question is, how good is this strategy, right? And again, so hint for, so I think for this puzzle, look up for two things. One is doubling strategy, but also look up for a notion of competitive ratio. So the competitive ratio is basically a ratio of the work done, in this case by this blind person, the distance he walked, divided by the actual distance of that box from the origin, okay, which was in this case, let's say some n, okay. So if you do some bit of math, you will find that this person is walking 1, 2, 4, 8, increasing number of distances till he hits the box when he walks distance n finally. This ratio comes out to be worst case 9. Okay. What is very interesting is that actually this is very celebrated result, that these mathematicians could show that this is the optimal strategy. So any other strategy used here will actually have a competitive ratio greater than 9. 9 is the best competitive ratio you can have, and this doubling strategy gives you that ratio. Okay. So let me repeat this again. We were looking at blind person walking on a straight line and finding the treasure. We said single direction is not a smart way to do. You have to keep looking in both the direction. For that, we designed a doubling strategy. To understand how good this strategy is, we look at the total distance traveled by the blind person and divide it by the actual distance of the box from the origin. It's called as a competitive ratio. And this ratio is 9 for the doubling strategy. But we also know that it is optimal. Any other algorithm will have a worse ratio than 9. Okay. So this is a very smart thing. Okay. That you can. So in the previous problem, we looked at marriage condition and we said that it's both necessary and sufficient. We can find the matching, perfect matching. Here we are talking about a competitive strategy which is optimal. Nobody can do better. These results are very hard to prove and these are very remarkable. Okay. Now let's do one thing. I'll probably just do one problem, maybe not this. I'll probably jump in the interest of time to this problem. It's again very interesting and it kind of builds on that competitive ratio concept. Okay. This is that decision to buy or not to buy. Okay. And I have named this character as Hamlet, who had this question, to be or not to be. So this is something again very common with us. Okay. And I want to ask you that question again, that what real life situation you see this is modeling. But look, our Hamlet here, he has to go skiing every day. And he does not know how long he will continue doing this, right? So he basically has a choice either to buy those skis or rent them. If he rents them, then it's a $30 per trip. If he buys them, it's $500, for the entire that ski set. Question is, what should Hamlet do? Should he buy on very first day? But remember, he does not know how long he will continue. Should he keep renting forever? But then he may go for skiing for hundreds of days, and you can clearly see it's more expensive, right? So, question to know all of you, and I think I'm sure all of us are Hamlets in some way or other. What will you do? How will you approach this? When will you buy skis? Or will you keep renting them all the time?
Sir, after 17 days, we will buy the skins, sir.
Okay, very good answer. And why 17?
In 78th day, the dollars will be 510, sir.
Dollars will be 510, equivalent to the buying cost. Almost, right?
Yes, sir.
And therefore, it's worth buying. Very good answer. I'll come to that skiing principle. But my next question to you is, do you see or face this problem in daily life?
Yes, sir.
See, I know number of people who decide on the first day of the year that they will start going to gym. Okay.
Yes, sir.
And some of them pay annual fee, but end up going to gym for maybe a week or so, right? I mean, any kind of shopping we do, right? This is, buy versus rent, right? So for example, let's say you move to a new city. You have to decide whether to rent a flat or maybe buy some small place, right? Which way is better, right? So this question of buy or not to buy, or when to buy is very common. We face it again. So as he rightly answered, or when to buy is very common. We face it again. So as he rightly answered, from the competitive ratio point of view, the right strategy is to rent till a point that cost reaches the buying cost. Okay. So there, so remember, this means he actually has to go skiing for 17 days. So by then it's very clear that he is keen on skiing, and there is no point in keep renting it. Best for him to buy it. So this strategy is too competitive. Now I already described competitive ratio to you. Had he already knew number of days he's going for skiing, it was a very easy decision for him. Let's say that he knew he was going for skiing only for 9 days, then it's clear that he should rent them. If in advance he knew he was going for skiing for 50 days, it is clear that he should buy on the very first day, right? Because he did not know this, he has to make this decision somewhere in the middle. What is that right middle is what we have been debating. And that middle, by this principle, is reached when the renting cost becomes equal to the buying cost. So I hope you appreciate this problem. See, what my idea of this session was, to tell you that many algorithms are based on certain principles. These principles are actually very intuitive. There is no rocket science in them. And several times we are already applying these principles in our real life, with dealing with different situations. So let me come to now one such situation. Okay. So I want you to take 2 minutes, observe this picture here, and share your observations. What do you find on this picture? Anyone? What do you observe?
It is about making pappu vadai.
Okay, very good. What else?
They have told how to make and the amount of ingredients, how much vadais will
Yes.
it make with this amount
Mm-hmm.
of ingredient.
Mm-hmm.
They have also included the making time and the make, like what are the requirements and where especially this item is daily basis they do.
Perfect.
And
Very good.
like yeah, for what time we can have this snack, like as a snack or whatever the timings they have mentioned. And they have also mentioned the main ingredients that has been added in this food item.
Yes. Right. And they also have given a picture, so you know how it may look. You know.
Yes, sir.
Right. No, these are very good observations. So let me tell you, and I'll also tell you why I showed you this picture. See, you observe that there are these different ingredients, but they are not same proportion, right? Of course, we add very little salt or little spice, so they have very different proportions. And you observe that something is, you grind it, something is you knead it, something you fry. They all go through very different set of transformations at different stages. And this recipe tells you how to do it, as you rightly said. So recipe is an algorithm, right? It's a very step-by-step procedure of how to do it. Obviously, a good recipe is something that will give you the right output, right? You also want to know at the end what you will get. You also want to have that output in a shorter amount of time, right? And I don't know. Again, I mean, this is a very old sort of movie of Amitabh where he's making an omelette. If you haven't seen this scene, just watch it. It's very fun how he just makes very bad job of it. But if you read this, if you see recipes and algorithm, you will, I'm sure, quickly realize that, especially in our Indian homes where mothers mainly do the cooking, they are all algorithms, right? And it's always actually a pleasure for me. I'm a very foodie guy, but it's a pleasure for me to see, especially if my mother is sharing recipe with someone, the way they communicate, they never communicate at this micro level. Many a times it's, relating to something else that other person may know and just suggesting some changes and all that, right? So this is how even algorithms talk to each other. They know common principles of algorithm making and they kind of communicate in a very similar language. Okay. So one thing you must appreciate is that our mothers are already great algorithmists, and since we are their kids, we should not be afraid of algorithms. I'm sure we all will also do very well. Okay. And I already mentioned to you a number of those puzzles where we saw many real life scenarios. You people already knew how to handle them. So you already know strategies and algorithms. It's just a matter of applying it to a real given problem. Okay. Now let me also tell you how algorithm is also a recipe, right? So I don't know if you have already done algorithms course. Ma'am talked about teaching it, and I'm sure she and other faculty members will appreciate that a typical algorithm will have also some of those ideas, right? Some principles we saw. And you have to sequence them, use them properly, to sort of arrive at a right algorithm. Okay. A typically good algorithm will have, very few, very strong, good ideas. Not too many. I mean, a complex thing is always to be looked at with suspicion. Typically, great things are very simple. Okay. Many great algorithms, if you study carefully, will have some very small number of great ideas. Okay. And of course, just write recipe, an algorithm, you want right output, you want it very quick time, using minimal number of compute resources and all that, right? So typically when you design algorithm, you will want to optimize on time, you want to optimize on space. In fact, you also want to optimize on user interactions. Okay. And you want to guarantee that the outcome will be optimal or the best possible, that you can get. Okay. So I hope you appreciate this, even if you haven't studied algorithms yet, that you want efficient algorithms that give the best possible output, right? So, so you can see that this is something again very natural to expect, and the job of algorithmist is to sort of do best on this. Okay. So, so why algorithm is also so close to us being Indians, right? See, this word algorithm actually it comes from a Latin book called Algorithmi de Numero Indorum. So, see what happened. I mean, if I go back in history, as you know, that the place value system of numbers originated in our land, in India. And the very first algorithms were how to add and multiply numbers, something we all did in our first, second grade in school, how to add numbers, how to multiply them. But that was a big thing. You can understand that even Greeks couldn't discover it. So it was a fantastic achievement of that, people then in India. And when Arabs actually became very powerful, they were trying to gather knowledge from all over the world. So Al-Khwarizmi was a very famous Arab mathematician who had actually studied a lot of work across the world, including in India. And what he had done was he had actually translated this multiplication summation methods in Arabic, and then it was further translated in the sort of Renaissance period in Europe, in Latin, and they had actually Al-Khwarizmi became algorithmy, you know, and that's how the word algorithm came. So it's a very interesting sort of, global thing that you see Indian civilization, Arabic civilization, and European civilization coming together to sort of derive this word, algorithmic. So that's algorithm. I think we should be proud that we sort of, it's a part of our heritage too. So something even closer association with algorithms, right? Now there are variety of different algorithms. I think that Kaun Banega Crorepati and Hamlet is called as online algorithm, where we don't know entire input and still we have to make a decision. I'm sure you people have studied some sorting algorithms. So quick sort, which is a randomized algorithm. Then that kahi na kahi koi hai, that matching problem is part of combinatorial algorithm. There are variety of algorithms, right? And I'm sure you will see some flavor of this in your coursework. Okay. Now algorithms come in all domains, as ma'am rightly said in the beginning. That um, I mean, algorithms are everywhere. They surround us. Any Amazon shopping you do is an algorithm. Any autocomplete that you see in your when you are typing message in WhatsApp or Facebook is an algorithm. Um, I mean, you name it, and there will be some algorithm at the back of it. So there are a variety of domains it gets applied, and that's why it's very important for you to have strong grasp of this subject. So we do number of interesting things. Probably in the interest of time, I'll not go through all of them. We will talk about one or two. So this workforce management was entirely that matching problem. Okay, how to assign right people to right project. Okay. Then in privacy, we have done number of algorithms, that uses graph algorithms, approximation algorithms, and whatnot. We actually did some very interesting work with radio astronomers and build schedulers for them, to use that telescope. So again, a kind of algorithm. So there are a number of such projects go on in TCS research, where we are coming up with some novel algorithms. With that, maybe I'll come to end of my talk. I hope you found it useful. So just a quick summary is, we saw how the word algorithm was derived. It's a very interesting story. We also saw that just not anyone, but our own mothers are great algorithmists. We also saw a number of puzzles relating to real life situation. And you probably now appreciate how you yourself have been designing strategies, that play a role in algorithms. And there are variety of different types of algorithms, and there are different domains they get applied. Okay. So that's sort of quick summary of it. Of course, TCS research, we do number of interesting things in algorithms across different research areas. So with that, I'd like to stop. If there are any quick questions, I'll be happy to answer. Otherwise, back to ma'am.
Thank you for sharing your insights and knowledge, sir. Your guidance and passion for education light the path for countless aspiring minds.
Thank you, ma'am.
Acknowledging the good that you already have in your life is the foundation for all abundance. Gratitude is the key to abundance. I would like to call upon Dr. P. Nagaraj Sir, Associate Professor in CSC and faculty sponsor of our Career ACM Student Chapter, to extend our gratitude. for delivering the vote of thanks and acknowledging the collective effort that make the industry expert webinar possible. Sir, can you please proceed?
Yeah, thank you, Vijaya. Good evening to all. Good evening, Sachin sir.
Yeah, good evening, sir. Good
Sir,
evening.
I hope you can remember me. We met in ASIM's chapter summit.
Yes, yes, sir.
Yes, sir. Yes, sir.
Good.
Thank
Nice
you,
to
sir.
see you.
Yeah. Yes, sir. Yes, sir. Okay, fine. Sir, on behalf of Kalasalingam University, our University Kalasalingam Academy of Research and Education, and we have 3 chapters, sir. On behalf of Karay ASIM student chapter, Karay ASIM women student chapter, and we have Madurai ASIM professional chapter. I would like to extend our heartfelt thanks to Mr. Sachin Lodha Sir, TCS, and now he will be Treasurer and Secretary of ASIM India. And congratulations to you, sir, Sachin sir. It's a very honor to us we have today for the webinar.
Thank you, sir. Thank you very much.
And even you have very despite of your busy schedule, you have accepted our invitation and interactive section made with us for your invaluable time. And I'm assured that our students will take your advice and to heart to and apply it to their continuous courses like data structure we have, DA we have, as well as all programming language courses, the fundamental courses C and Python, everywhere we can apply. And at last, I would like to thank our management and our department for organizing this webinar successfully. A special thanks to all our students, volunteers, and Karay ACM core team members for their excellent coordinations. And last but not the least, I extend my heartfelt gratitude to all the participants for joining us and making this webinar as a grand success. Thank you, one and all.
Thank you.
Thank you, sir. Thank you, Sachin sir. It's a special thanks to you. Your support always we need for Karay ASIM student chapter, women chapter, and Madurai ASIM chapter.
No, I mean, our support is always with you, sir.
Thank you, sir. Thank you so much.
I hope to see you and students again for the next chapter summit.
Sure, sir. Sure, we are ready.
And it's coming closer to you. This time it will be in Bangalore.
Okay. Fine, sir. I hope it's in Bangalore, right, sir?
Yes.
Yeah, we have yes, we have appeared in one meeting.
Yes.
Good.
Thank
sure,
you.
Sir.
I will then sign off now. Thank you, everyone. Take care.
Yeah, thank you, sir. Thank you so much. Thank you all.
Yeah, thank you. Bye.
Thank you, guys. Thank you for your cooperation.
Yes, you may leave now. Thank you. Anuga, ma'am?
Thank you.
Yeah, thank you, Lokesh.
Thank you.
Yeah, thank you, Sedu.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, guys.